Okay. So the different terms we're going to look at today: direct variation, reciprocal, constant of a variation, inverse of a variation. Some of these may look familiar, some of them may not, but I assure you that a lot of what we're going over today, you're probably going to be like, oh yeah, I totally remember that. So before we do this, just a brief review of what a reciprocal is. So the reciprocal of a number x is expressed as 1 over x, because basically when you add two reciprocals together, or when you add a number and its reciprocal together, what you want to get is 1, not add. When you multiply a number and its reciprocal together, what you want to get is the product of 1. Reciprocals are super easy. Basically, if you see things in terms of a fraction, a reciprocal is just flipping your fraction over. So find the reciprocal of 3 over 8. Basically, to find the reciprocal, you would just flip that fraction over, so it become 8 over 3. Okay, so that's the gist of it. Also, if you have something that looks like this, where it's just the whole number, find the reciprocal of 7. Well, 7 in terms of a fraction is 7 over 1, because basically you're going to divide 7 by 1, and that would give you the whole number 7. So this is just the equivalent of 7 in a fraction. And to find the reciprocal, you basically just flip that around and you get 1 over 7. Okay, and what it means as when you add the number and its reciprocal together, you get 1. Basically, if I were to add 3 over 8 and multiply it by its reciprocal, I keep saying add, multiply it, what you would see here is you get 24 over 24. 24 divided by 24 is 1. So whenever you multiply a whole number and its reciprocal together, you want to get the product of 1. So that's how you know you found the right reciprocal. So look, 7 times 1, 7 over 1, multiplied by 1 over 7, 7 divided by 7 is 1. So that's basically the gist of a reciprocal. You're basically just finding the equivalent of the fraction and then flipping it. Okay, so that's a reciprocal. Any questions about this? Okay. So representing relationships between quantities. So there's different ways to represent a relationship between quantities. Specifically two quantities. You can express it using a table or a graph or an algebraic equation. So the table, the graph, and the algebraic equation are all equivalent to each other. It's just different ways to represent the relationship between those two quantities. And what we're going to look at is different types of relationships between these quantities. So how are x and y related to each other? That's basically what we're going to get into today. So the first thing that we're going to look at is direct variation. Direct variation is pretty simple. It's basically just a linear relationship between two quantities. As one quantity increases, the other quantity will increase or decrease depending on what your constant amount is. The formula for direct variation is 1 equals k times x, where k is your constant variation. And then the constant variation is basically the same thing as the slope. It's what the constant rate of change is. If you have a k that is greater than 0, you're going to have a positive slope. If you have a k that's less than 0 or negative, that's going to be a negative slope. So basically, direct variation, we'll look at an example, but it's pretty straightforward. So like we saw in the previous example, we had y equals 2 times x, where 2 would be the constant variation, because we have our direct variation equation, which is y equals k times x. So as you can see there, k is substituted by 2, which means that 2 in this instance would be your constant of a variation. Okay? So basically what the direct variation tells us is that this is how y varies with x, or x varies with y. It's basically how our two components relate to each other. So say we had this equation right here. And basically, let's say that this y was telling us the cost. 2 told us that each cupcake was $2. And then x told us how many cupcakes we had. So let's say that's the relationship we have here. So that basically means that the cost varies directly with how many cupcakes you get. If you get one cupcake, well, then you only spend $2. If you get two cupcakes, then you'll spend $4. So that's basically what direct variation is. It's like telling you how those two things are related to each other. Cost is related to the amount of cupcakes depending on the price, which is 2. So basically it says if x is equal to 5, plug 5 into the equation and solve for y. So say now that I want to know, okay, if cost varies directly with the number of cupcakes I have, what is the cost of me buying 5 cupcakes? Well, then you would just plug that in. So y equals 2, x is 5. So then y is equal to $10 or 10. So basically, if I buy 5 cupcakes, I have to spend $10 because each cupcake is $2. That's basically the gist of direct variation. Okay. So there may be instances in which you're already given the constant, but there may be instances when you're asked to find the constant. So this one says, if y varies directly with x. So basically, if you see this statement varies directly, then you'll know you have a direct variation. If y varies directly with x, such that y is equal to 15 when x is equal to 5, then what is the value for y when x is equal to 12? So basically, what you want to do, if you know that y varies directly with x, then you know you have it in this equation. Because this is the equation of direct variation. We know that our y is 15. We're looking for our k in order to solve, and we know that our x is 5. Right? So this gives us this equation. We're not told exactly what our constant of the variation is, but we are told what our y is and what our x is. And so what we can actually do is we can solve for our k by isolating k. So divided by 5, that allows us to cross this out, which tells me k is equal to 3 because 15 divided by 5 is 3. So now that I know that k is equal to 3, I know that this is my equation. If k is 3, then I just plug it in here for k. K is now 3. Okay. So now I'm being asked, what is the value of y when x is 12? So now I'm told, okay, now x is 12. What is y? So basically, I would just plug in 12. Twelve times 3 is 36. And so when x is 12, y is 36. And when x is 5, y is 15. And those two y's and x are varies directly to each other. Okay, any questions about what I did here? Questions, concerns? Okay, so here we're given exactly the direct variation or the constant of the variation, and we can use that information to solve. Or here, what we can go ahead and do is solve for the constant of variation and then use that to solve further. Okay. So here is again just another example of direct variation. And this is kind of the types of word problems you will see. This says the number of calories burned by running varies directly with the number of minutes of physical activity. So my y varies directly with my x. If they vary directly, then they will follow the equation y equals k times x. Okay? If a person burns 93 calories after running 3 hours, so 93 calories after running 3 hours, I'll do 3. After 3 minutes, 93 calories. How many calories will the same runner burn in 1 hour? Okay, well, I know that my y varies directly with my x, so that means that I need to find my constant to create an equation that represents that relationship. So again, I would do 93 equals k times 3, where 3 is my x and 93 is my y. I would divide by 3 to find my k. K is 31. Now that I know k is 31, I can use this equation, y equals 31x. That tells me y varies directly with x, where my constant of variation is 31. So now I want to know, I can answer the question, how many calories would the same runner burn in 1 hour? However, because I originally worked with minutes, I want to make sure I'm staying with the same unit. So I want to change this to minutes. And 1 hour is equal to 60 minutes. Okay, just make sure you keep the same variables, calories and minutes. So that means my X is going to be 60 because I needed a minute, 60 minutes. So I just plug that in. 31, X is 60. When I plug that in, I get Y is equal to 1,860 calories. So basically, I will burn 1,860 calories if I were to run 60 minutes. Okay. So that's how you would solve a direct variation problem. Okay. Any questions? Okay. Now we're going to get into something a little different. You may or may not have seen this one. I know you probably saw direct variation before, but we're going to look at inverse variation. So the inverse variation is basically just the reciprocal of your direct variation. So that's why learning about reciprocals was so important. In this one, as one quantity increases, the other quantity decreases by a constant amount. Okay. The formula for inverse variation is this one right here. Y equals K over X. Where K, again, is the constant variation. The formula can also be written like this. X times Y equals K. And I'll show you why that is the case. Say I have my original formula like this. Why can it also be written as X times Y equals K? Well, basically because what you can do is you can actually multiply by X on both sides to isolate K. And when you do that, you get X times Y equals K. So they're basically one and the same thing. Whichever way you choose to represent it, you can go ahead and do that. Okay. So how do I find the direct variation or the inverse variation of a specific, in this instance, a table? Well, basically, you'll just identify one of the coordinates on the table where you have an X and Y, and you want to see how those two are inversely related to each other. So this would be my X, and this would be my Y. And so I need to find what my K is. What is my constant of variation? Okay. So how can I go ahead and do that? Well, my Y, I'll use this one. Y equals X over K. Here I see that my Y is 7 over 4 is equal to K. I'm looking for my K. And my X is 2. So this is what I'm left with. Okay. Well, I need to isolate my K to find my constant variation. So multiply by 2. Multiply by 2. If I put 2 times 4 over 7 into a calculator, what I'll get is 7 over 2. And I'll see that 7 over 2 is my K. Okay. So that's one way to do it. Another way to do it is if I wanted to use my other equation, this one right here. I would just do the same thing, plug in. So I have 2 times 7 over 2 equals K. That's basically what I did. 2 times 7 over 2 means that my K, or 7 over 4, sorry. Means that my K is, again, equal to 7 over 2. So either way I want to go about solving it, that's how I can find my K. All right, any questions about this? So basically you're just plugging in these different values into the inverse variation function, whichever one you want. And then by doing that, you're able to solve for K. So like we saw here, there's 2 different ways that you can go ahead and represent your inverse variation. These are basically the same thing. This is just basically you actually doing 7 over 2 7 divided by 2 is 3.5, so that's why it's just left there as 3.5. Either or, they're the same thing. A relationship of an inverse variation. The graph will never touch the y-axis, and the graph will never touch the x-axis. So this is kind of how we represent those inverse variations. And what you'll notice is those graphs never touch the y, and they never touch the x. But they're very much always graphed like this. They kind of look like a curve, whereas a direct variation is a linear. It's straight. Okay. And so here's actual word problems, and this is how you'll know, oh, I need to use inverse variation. This one says, Marcel is building a garden behind her house. She wants her garden to have a total area of 200 square feet. The length and width of the garden vary inversely. So if I know, if it tells me varies inversely, then I know I need to use my inverse variation. That is how I will tell whether I need to use direct variation or inverse variation. Here it tells me varies inversely, so I'm going to use my inverse variation. Okay. What will the length of the garden be if the width is 50 feet? Okay. Well, my length will be my y, and my width will be my x. Okay. So basically, y is your length. So I'm going to put length is equal to 2,000, which is my k, 200, which is my k, and I know my x is my width, so I'll just put w. So that is how my length and width relate to each other. Okay, so now I just plug in. I want to find what will the length of the garden be if my width is 50. So I'm basically plugging in 50 for my width. And what is that telling me to do? It's just telling me 200 divided by 50, 200 divided by 50 tells me that my length is 4. Okay, so in this problem, what I really want to be able to identify is that I have an inverse variation. Identify what is my x and y, plug that into my equation, and then solve for what I'm looking for, which is what will the length of the garden be if my width is 50? Any questions about this? Okay. So we saw direct variation, which the equation is y equals k times x. This is a linear relationship. If I were to graph this, it would be a straight line. And as one quantity increases, the other would either increase or decrease depending on whether you have a positive or negative constant variation. Your inverse variation, on the other hand, can be represented as y equals k over x, or x times y equals k, whichever way I choose to represent it. This is the reciprocal of our direct variation, and it is graphed by two separate curved pieces, which we just saw. But in this instance, as one quantity increases, the other will decrease. Okay. So inverse is basically your reciprocal of your direct variation. Okay. So for example, you see something like this. You may be asked, okay, what type of variation is this? Is this a direct or an inverse variation? Well, your first giveaway is that your graph is represented as a curve and not a straight line. So that means I must have an inverse variation. What you also notice as your x values increase, your y values decrease, which also indicates an inverse variation. And so if I wanted to, I could actually create an equation for this. How would I do that? I'll just choose a random coordinates, this one right here. And now that I know that I have an inverse, I can plug that into my inverse variation equation. This would be my x, this would be my y, so I just plug that in. Y is 1/2 is equal to k over, my x is 1. Let's isolate my k. which gives me k is equal to 1/2. Now I can just plug that back in. So y is equal to 1/2 over x, or if I wanted to write it in this form, that would just be x times y is equal to 1/2. Either one works, but that equation does represent the function that we see on top. Okay, any questions? So basically what we're able to do here is we're able to write a direct variation equation, or we're able to write an inverse variation equation. Direct variation is y equals k times x. Inverse variation is y over k times x. In both instances, k is the constant of variation, so k would be the constant way that those x and y's are relating to each other. Pretty straightforward, okay? And we'll go over some more example problems on Monday, but does anyone have any other questions? Questions, concerns? No? All right. If there's no other questions, you guys may log off. Have a great weekend, and I will see you guys on Monday. Bye, guys.